So now we are introducing a calculus inside your strain system, stress strain system. So we are considering a differential form of a strain. So let us consider we have got a 3 axis, or we are in a space which is x, y and z. So we consider a single point which is P, and the coordinates of P are x, y and z. So assume that there is some disturbance given to this particular point. This particular point could be on any particular body. So we are not taking any particular body as a whole, rather we have taken a single particular point. So at this particular point, if there is some disturbance F which is given, and due to this disturbance, so let us consider this point gets shifted to another point called P dash, where U, V and W are the coordinates of P dash, and rather this is nothing but a functions of x, y and z. So we have written this u, v and w in terms of functions. So they are not particular any values, or rather these are functions. So if that is the case, now if I ask you to tell me what is the normal strain and what is the shear strain in this particular process, then in that case it's quite easier for us to identify that is epsilon xx will be nothing but partial derivative of u with respect to x, partial derivative, then epsilon yy will be partial derivative of this v with respect to y, and this epsilon zz, which is a normal strain in z or along z direction, this will be partial derivative of this w with respect to this z. So once we have solved this normal strains, then if we talk about the shear strain, it's easier to remember this, that is phi xy. So how to remember this? So say suppose if you are writing phi xy, then simply write dash plus dash, and here since here you have got x, so here you write dou x. Here you have y, so here you write dou y. Then what you do, just opposite of this corresponding of y, what is v, right? Corresponding, so here we have corresponding to x we have u, corresponding to y we have v, corresponding to z we have w. Fine. So remember this funda. So here we have got x and y. So once we have written xy, so in the denominator you write first x and then you write y. So corresponding to y you have v, corresponding to x you have u. Alright, so if you add this, you will get the formula for this. Now phi xy will of course will be equal to phi yx. Same process you apply out here. Yeah, here I have written phi yz. So instead, see, since you have written phi yz, so first you write y, that is dou y, then you need to write dou z. Corresponding to z, you know it's w, so here we'll be writing dou w. Corresponding to y, it's v, so we'll be writing dou v. And this yz will be equal to zy. Now the last one, which is also same, phi xz will be equal to dash plus dash, right? Now here we have xz, so here we'll be writing first dou x, then we have z, then we'll be writing dou z. Corresponding to z we have w, corresponding to x we have u. So if you add this, you'll get phi zx. Alright, so this was your differential form of strains. We'll solve the problems related to that, so it will be more clear to you, but it is quite more imperative to remember this format because these are more frequently asked on your exams. See you in the next lecture. Till then, bye.